Hello everyone, Matt Hoots here, and welcome to another episode of Rate It Green Interviews and Reviews. As a green builder, I'm always looking for ways to help my clients save money. If you're looking at making decisions on windows, insulation, HVAC, it's always nice to know what the return on investment is going to be between one product and another, especially if you're looking at performance. Well, the good news is there is a tool out there, and there's several other tools as well, but in particular, we're looking at a tool called Cove Tool, and we're going to interview the founder of Cove Tool, Patrick Chopson, to see what benefits and also what features it has to help building owners, architects, and also builders make decisions on building products that help the end user be more comfortable and sustainable.
Cove Tool is a building simulation tool, but it's more also focused on design. So there's a lot of like aspects about it that help you make interesting graphics that look cool in terms of like energy, daylight, water, glare, radiation. We're actually adding like a COVID score that tells you how if you can maintain social distancing. It does things like so the reason why it's called Cove Tool, it's a cost versus energy tool. This is the original use. So we actually do like optimizations of building performance versus the cost. So we have like a database of all the different costs from different manufacturers for their retail pricing. And then we can use that to run thousands of energy models using machine learning to help us be able to understand the best combination of components that go into the building versus the energy and lead and payback and embodied carbon, things like that. So it's kind of like
Are those costs built into the database as part of the tool?
Mm-hmm. Yeah, it's all kind of like packaged together. The goal is to basically create an end-to-end process where people can do all the things that they need to do on their project without having to hire a consultant because everything's automated. So we try to automate all the different pieces. So like if you're running a daylight simulation like we see here, it actually imports all the context buildings for the entire site. So this is actually Tech Square over at Georgia Tech.
Okay.
And imports all those buildings, and when it runs the energy model, it's actually taking into account all that context for the daylight simulation. And you don't have to be an expert to use Cove Tool, which is also something that's really cool. So like maybe if you're like somebody who's like an intern or maybe a contractor or somebody who's never done a daylight simulation before, you can run it because everything's set up by us. So we've gone through every single climate zone and energy code, and we've gone and digitized all the correct inputs for like what you would be using for wall insulation or the glass to meet energy code.
Okay.
And then we go in and then help people by setting all that stuff up for them ahead of time. So you only have to change the things that you know. It's all web-based, so it's running in the cloud. So if you're like somebody who's working from home, it's kind of hard to access your server in the office. So with this, it's kind of like Netflix. So when you log in, checks the user out of your plan, things like that. It has plugins to like Rhino, Revit, and SketchUp for your 3D modeling tools. So like if you're anybody who's making anything in 3D, you can import it. We also have like other tools that plug in like AutoCase and then ArchiCAD and things like that as well.
Okay.
So yeah. So hopefully that kind of gives like a good understanding of like what Cove Tool is. What's really cool, like I can just kind of go through like how you would use this, and maybe that makes the most sense for folks. And this is a kind of a cool thing to show to clients, like if you're trying to be, the chocolate or the thing that's different out there. It's really super helpful to have like a very graphical thing to show people. For example, like in this case, like I could actually see what percentage of the time a certain part of the floor plan would be daylit. So anything that's like yellow to red is like passing for lead, which means that more than 50% of the time you wouldn't need electric lights. Okay. So what we're showing here is like we can turn off the walls and roofs and all those things so we can look at just the analysis. Maybe I'll leave the interior walls in. You can see like how this particular office has a certain amount of daylight that's getting in halfway through the room. It's still passing, but this blue area back here is not. So the goal would always be to get to like 55%. So this can help you revise your design. Like let's say I made a house and I wanted to make sure that one wing of the house where everybody was going to be had good daylight. I could actually use this tool to prove that my design with the big windows actually made sense. And that if I made them smaller, you wouldn't get that daylight. Because a lot of times people just want to know with an actual number, how effective is this design? And a lot of architects and engineers, it's hard for you to visually show a client like why something works or doesn't work. And using this, you can fly around, like even if this was a high-end house or something like in Buckhead or somewhere else in Atlanta, we could actually show them like, hey, 50% of the time you could just sit in here with natural light. And that's a pretty cool thing. Or you can say, but we want to make sure there's not glare. So using this is our glare simulation, which is ASE. So it shows us that the green is passing. So we can see that like everywhere is looking pretty good except for this one wing of the building where we got this black. It's going to be really bad. So then we could say like, because of this, we need better overhangs, or we need some frit glass, or we need some kind of like tree that we need to plant here. There could be many different things that we could try, but it would show at least the client like why you're doing different things. And you could say like, we don't need fins over here, but we do need fins over there. And it can help justify cost savings as well for things like that. So we also have like a radiation study, and you can see where the most intense sun is hitting it, which is pretty cool. So then you can say like, I know where the solar panels should go. So like maybe if you're trying to, let's say if this was a house, maybe there's like a tree nearby, and you can model that tree, and you could say like, actually that one part of the roof would be a terrible place to put your stuff because it's all purple. So we're going to put the solar panels like over there. And if it's
so essentially
kind of
commercial in downtown Atlanta, unless you have a big building blocking it, there's really no excuse for not using solar.
Exactly. Because this is Tech Square. This is like pretty dense. But this particular, just the way the street's laid out, it's nice and wide between, like this is the Barnes and Noble bookstore over there for Georgia Tech. Of course, I can turn it off for graphical purposes, but it kind of lets me design more contextually, which I think is really important as when I used to teach also, and it's always trying to get students to think about like your building is not like in the Matrix where it's just like all by itself in a white room. There's like other things around you, and you should probably take into account how your building affects the context, like maybe with shadow studies. I can also say like, okay, this area is going to be in shadow in the summer, but maybe if I go to like, or this is the winter, but if I go to the summer, like maybe to, let's say like today, like it's the 24th. So we can say like right at the current time, which is like 10, let's say 10:15 or 10:30, the sun's going to be over there. So you can see that like, actually, if I want to design, if I knew that people were going to get picked up from a bus stop over here, it would be a better idea to maybe put that bus stop on this side than that side, because then I wouldn't be having people staying in the sun in the morning. That makes sense. Things like that just are really, really helpful as an architect or designer or whatever, just to make sure that you fully understand what it is that you're proposing, and just being able to prove that you did something that makes sense is like really the name of the game, especially now, because like a lot of clients are used to working in industries like finance or banking or like marketing or whatnot, where their whole day is just looking at data all the time and understanding how that data affects their decision. Yeah. And then they go talk to an architect and there's like, hey, there's no data here. They're like, if I'm a designer and I say it looks nice, they'll be like, well, it costs money too, so why do I need to add this unnecessary thing? And what we do find, and I'll show you this in the optimization while that runs, we do find that like typically in Georgia, you can achieve even for a single family home, about a 2 to 3% cost reduction through optimization and a 40% reduction in energy consumption. So you can get like a cheaper building that actually uses less energy just by using optimization. And generally speaking, if it's a single family home, the kind of rule of thumb would be 2x6 walls, 24 inches on center. So you use like a little bit thicker insulation, but you actually use less wood. So it's 40% less wood if you use 2x6s versus 2x4s. It's also, the building goes up faster and it uses less labor to build with 2x6s because there's fewer cuts. So you end up building a faster project. Of course, you got to be. You can use also the advanced framing technique. Most contractors know how to do that. Then you would use probably something like a 0.22 or 2.5 for your U value, solar heat gain coefficient for your glass, and a few other things, and you can actually build the building for less. So there's not, but like for a commercial building, yeah, obviously you have more options, and or even for a residential building, you could do 3 types of HVAC systems with 4 different types of windows that you're considering, like Marvin versus Pella versus some Georgia window, some manufacturer like that. And then maybe I could look at using a Nest system versus solar panels versus 2 different types of insulation. And I could figure out what's the best combination of all those things, because typically the human, you can't analyze all those different combinations. So like what we're looking at here is each of the different things that I'm looking at, like wall insulation or glazing or like roof R value or skylight assemblies, different HVAC systems. I can put all these different things in, and then the costs are automatically assigned. Like for example, if I put in like a fan coil system, it has a cost for the entire system based on the square footage of the project. It has a description, and I can also put in the embodied carbon of any of these inputs as well. So that's like how much carbon it takes to make that thing, and then bring it to you on the site. So that's like a really big thing that a lot of architects are into right now, especially if they're trying to hit the 2030 targets. You can do things like different embodied carbon for your structure, different cost per square foot. So you can pretty much put costs in for all the different components of the building. And then when you run those bundles, it'll tell you the cost of the baseline, which is like code minimum, versus the option that we picked, how much more or less money we'd spend. So you can see here, I could say I just want options. I can click and drag. You can say for cost premium, which is your construction cost. I can say I want to pick options that cost less than 0. So things that are cheaper than the code minimum. I want to do the lowest energy building that costs less than my code minimum. And I can see that for negative $7,000, I can get a 10% savings in energy over the energy code, which recently updated in Georgia. Or I could do like, I just want the lowest energy building, but I want to use the least amount of embodied carbon, maximum lead points. And I can see here that if I spend an additional 40K, I can actually get a 17% improvement on that. So the more options that you give it, and to look through with the machine learning, the more likely it is that it's going to find a combination that costs less than your current thing that you're looking at.
So so for residential and or commercial, are there some solid go-tos, or you pretty much have to model this for each particular building, because every building is different. So we can't just assume a certain level of insulation and a type of window, because it may not have a payback compared to another one.
So you can use the payback as well here. So you could say you want things that are less than 10 years. I could do that. And I could actually just look through only bundles that meet that criteria as well. So we have payback and all that. And so what's really cool is when you start a project here, it actually we pre-populate the first 3 options for you so that it will run and give you some interesting results. And then that usually is enough to get people excited, and then they go in and add more things to it. It's kind of usually how it works.
Now, does this take life cycle into consideration for the mechanical equipment?
No, I guess it's just factoring in like the payback is a simple payback based on the electricity utility rates, which are a function of your location. So you can change them on this baseline energy page. You can actually go in here and set whatever your electricity utility rate is. So if I was a university, I might be getting my electricity at a cheaper rate than like a retail consumer. But we put in the current retail or commercial rate depending on what type of building it is. Because you can do single family in here, which is kind of like one of the options is a single family home. And then it would pick like the residential electricity rate.
So that's interesting. So you mentioned that so the payback analysis is actually going to be better for commercial than it would be a university if the rates are different.
And that can be a factor because, maybe most universities though, like Georgia Tech, we've done quite a few buildings on Georgia Tech's campus have used Cove Tool. that's why they've been able to get higher performance buildings lately over there, like the new student center. Use Covetool for everything. The new student center at Emory also used Covetool, and they achieved $850,000 of savings, and they improved the building performance by about 40%. Wow. For the new Emory Student Center. So like after that, Emory is like, okay, you're not doing any projects on campus. And it's interesting, the word's gotten out. Like we heard the other day that Princeton now requires that all new capital improvement projects on campus use Covetool, just because the savings are so enormous that people can't ignore it.
Well, I mean, especially if you're trying to show it to the people that are spending the money, they're looking at the bottom line, that you make this investment now, but these are the reduced operating costs. I mean, that for people that actually understand a spreadsheet, this is a very powerful tool, it looks like.
Right. And we do a lot of things like we actually can, when you click on the generate report, it actually makes 11 by 17 report that a consultant used to have to make for you. It gives you your walk score, your transfer, bike score, energy use, gives you your benchmarking against national averages so you know how well you're doing. Also gives personalized recommendations that are what are the things you need to do to reduce the energy in your building and what inputs you could edit. So this is all like for kind of giving you the guidance that an engineer would typically give you, but it's all kind of like automated. Water use, passive strategies. So these are all the passive strategies that work for your location as well. So for example, like here in Atlanta, almost all the passive strategies work except for 2. So if we click on this, it takes you to the 2030 palette, where you can then see a lot of case studies on how that other people have done that. Get a lot of like recommendations, tools, resources, books. Of course, Covetool is one of the tools. All your weather diagrams, just things that like take time, that if you're like a small office, like a five-man shop, you don't have the capability in-house to generate this stuff, but with Covetool you can. So we do see like some of our users are like, maybe 1 person, 10 people. Now they have the same capabilities as like a mega firm, which is pretty cool. You can also do things like it calculates your psychometric chart. So it tells you like what percentage of time a certain passive strategy will be effective. So for Georgia and Atlanta, we can see here that using this orange square, you can see that like internal heat gain is a really big deal. So harvesting heat from your like people or appliances or like equipment or things like that. And then dehumidification obviously is helpful for the summer. But what most people don't realize about Georgia, especially Atlanta, is that there's actually slightly more heating days than cooling days. So even though we have muggy hot summers, our winter and shoulder months are
it's like, last time I checked, like 3 or 4 more, right? It's like people don't realize that. Yeah, because I'm really surprised that they're constantly increasing the threshold for cooling, but they don't really affect heating, which is a frustration to me because that really affects the building envelope when it comes to open combustion equipment. That and water heating. I wish they would just make it where nothing is atmospherically vented, because it just makes it causes lots of problems for me when I'm trying to deal with existing houses and new houses.
Exactly, because like an existing house, like if it's historic, someone probably put some wonky insulation in there and then forgot to seal that. Now you got like mold everywhere. It gets crazy, for sure. But yeah, I guess like the thing that I always think about is the AIA doesn't really tell small firms or residential firms that they should be doing this stuff, even though we as architects have an outsized impact on climate change. Buildings are 40% of carbon emissions nationally and internationally, but in Atlanta itself, buildings account for 60% of the carbon emissions, according to the mayor's office of sustainability. So that's like pretty mind-blowing. You see all these cars driving around, but in reality, it's the buildings that are using all the carbon from the grid to be able to produce that power.
Patrick, on behalf of the Rated Green community, we do appreciate you taking the time to explain the software, and we look forward to getting to know you better.
All right, have a good one.
Bye.
All right, take care.
Thanks for watching this video. For more information on topics like this, we invite you to search for other products, services, companies, and people on the Rated Green directory. Unlike other websites, searching is free. Listing is free, becoming a member is free, and listing your green products is free.